Load distribution parameter load curve. Definition of the load curve. The curve showing the variations on the load power station with respect to the time. The power demands of different consumers vary in accordance to their activities. The result of this variation in demand is that the load on the power station never constrains, rather it varies from time to time. Daily load. The different load: domestic load, commercial load, industrial load, base load and the peak. The types of load curve: daily load curve, load variation during the whole day. Monthly means it converts daily load curve into a monthly date. Yearly load curve from the monthly load curve. Load duration curve, integrated load curve and curve. The importance of the daily LC. The daily load curve shows the variation of a load on the power station during different hours of the day. The area under the daily load curve gives the number of units generated in the day. Units generated per day is equal to the area under the daily load curve. The highest point on the daily load curve represents the maximum demand on the station on that day. Average load is equal to area in kilowatt hour under daily load curve divided by 4 hours. The importance of the daily load curve is load curve, it is the ratio of the average load by the maximum demand. The average load into 24 divided by the maximum demand into the 24, that is equal to area in kilowatt hour under daily load curve divided by the total area of the rectangular which load curve is contained. Load curve helps the selecting the size and the number. It helps the preparing operating schedule stations. Load duration curve. The load duration curve is an arrangement of all load level in a descending order of the magnitude. The area under the load duration curve represents the energy demands of the system, can be used in economic dispatching, system planning and the reliability evaluation. It is more convenient to deal with it at the load duration curve. This is the graphical representation of the cumulative hours and the percent of the peak loads. Difference between the load curve and of summer and the winter, the graph representations. So integrated load duration curve, a plot of a number of units for a given demand is called as an integration load curve. On y-axis, load demand in the kilowatt and the megawatt is plotted, while on the z-axis, corresponding number of units generated are up. Integrated load curve, this curve is obtained from the load duration curve. Let the load demand be 3 km from the load duration curve in section 1. The number of units generated corresponding to this demand will be area under section 1, which is show as an U1 and integrated duration. The number of units consumed by the load up to a particular time of the day can also be shown on the curve, which is called the curve. The mass curve is the plot accumulated of an inflow or outflow versus time, the mass curve of the supply. From the past records, determine the hourly demand of 24 hours of a typical days. Calculate the plot cumulative demand against the time and thus the plot the mass curve of the demand. The storage requires us sum of the two maximum ordinates between the demand and the supply line. Repeat the procedure for all typical days, maximum, average and the minimum average, and determine the maximum storage required for the. This is the mass curve demand which is regarding to the time. The daily demands of the three consumers are given below. This is the time representation. Please refer this diagram for the representations. This is the maximum demand of a consumer 1 is 800 watts, maximum demand of the consumer 2000 and the maximum demand of the consumer 1200. So LF for the consumer 1 is the energy consumed by. This is the calculations we are having to find the maximum demand of the day. And this is the diversity factor and the station load factor.